Hello. In this episode, we'll see how to clean up data using Pandas. So before you run the machine learning, the data usually getting from, let's say, from websites may not be completely cleaned up for you. So you may need to do this, and we'll see here how to use Panda to do some of the common tasks. Some of the common tasks, of course, upload the data and explore and see how the data looks like, and then change the column names if you want to, or drop or keep columns and certain variables that you want to keep for analysis. And then how to handle missing data or duplicate data. Actually, here's duplicate data. And then sometimes you want to create some other variables depending on the bins, like high, medium, low, something like that, and then finally how to save it. So here is a code I prepared. So the Google Drive. So it's the 12th episode. So in this particular case, actually this is, maybe this is, okay, so this is the data that the file that will access and clean up the data. But let me first mention something about the data. So today the data will manipulate will be about mortgage origination data. So HMDA is the database name from the data. And if you go to consumer finance website, so what this is, here's a little background. So in home mortgages, the government cares a lot about the mortgages are given fairly to all Americans, and the financial access to is being done fairly. So, and for that matter, the Consumer Financial Protection Bureau and some other bureaus like the Fed and FDICs, OCCs, they do constantly monitor the mortgage origination terms. And for that, they do collect this information. So, and it's also being shared to the public for them to see. So here, and this is called the Home Mortgage Disclosure Act. That was the law that mandated to have it publicly disclosed. And here's the information. So today, I think we are just going to do a small segment of it, like the Delaware data for all. So you can just have the ones that are passed and getting mortgages, the originated mortgages, or you can have it denied and accepted mortgages. Here, all right, let's see. Okay, it's in Delaware. So in 2017, let's download the 2017 data. Okay, so here is the data. I am going to bring it here. And it's zip file, so you have to unzip it by extracting it and click it. Of course, I did it. Usually before, if you can, it's a good idea to take a look at it with your own eyes and see how the data looks like. Okay? So here's this home mortgage data, origination data. So the year is here, and there's some unique IDs, and a number of places do have this data coming. HUD, the Housing and Urban Development, or Consumer Financial Protection Bureau, and all the sources. This is loan type, conventional loans, or FHA insured, or but these are all different types of loans. And also depending on the property, is it a 1 to 4 family housing, or is it a multi-family housing? All kinds of things, isn't it? You can see the ethnicity of or location, the state, the metropolitan area, the race of the applicant, isn't it? So a gender, and whether it was denied or not, and why was it denied. the applicant income, which is probably very important, isn't it? In thousands. And also the region that the application is from, the population, how much is the fraction of the minority in percentage, average family income, and all those kind of characteristics. But you can also see that sometimes it's missing here. So maybe you don't want to use all these columns. Like if you want to use this column here, then we'll have almost everything missing, isn't it? That would be not good. So these are the kind of things that we want to take care before actually running it into a machine learning algorithm. Okay, so let me just do that. Okay, so now we have seen the data. So that's where the data comes from. So the first thing is that we want to read the data. So I guess we'll be needing Panda because we'll be cleaning up the data with the Panda, but NumPy, Matplotlib for plotting, and some statistics plotting, maybe with Seaborn can be done. Okay, so and then we need to import the data. So I am going to upload. So we have done it several times, so I'm not gonna harp on it, but do need the data here. And it's data, so it's gonna take maybe a minute. So let's come back when it's done. Okay, so it's being read in on the computer, but now we have to read it in the Python program. So here is the Panda. Panda is nicknamed as PD. So the read CSV function, and then the file name. This will read in the file. So that was quick. So after you read in the data, I guess the first thing you want to do is how does the data look like? Again, as I did, if you have Excel and it opens up in Excel small enough to do so, it's a good idea to check it. But if not, here is a way to see it in Python programs. So the shape command shows how many rows and columns it has. So, it's many rows, and also the data actually 78 columns. It's a lot. The name of these columns as of year, respondent ID, race, many things are here, isn't it? And then if you are curious and want to see, let's say the top first 5 data points, head and then the number shows you here. And then you can see sort of a quick overview of those. So you can see all of them basically here, isn't it? You can scroll it down and see all of them. Also, what data types are there? Especially, is it a number or is it a character or something like this? And so the D type shows you which variable is actually not a number, which ones are like the floating numbers and stuff. One thing that we probably are interested in is for each variable, get the summary statistics, the mean, medians, and all that. So you can quickly check how that looks like. Of course, it will only do it for numeric variables. So now that you have a good idea of how the data looks like, maybe you don't like some of the variable names that we typed here. We want to maybe turn everything into small capitals and the space don't leave spaces, things like that. So have an underscore instead of a space because some old-fashioned operating system may give errors for this. Okay. So we changed the name to all small letters and then have the space in place to underscore. And there are 2 ways of choosing columns. You can delete the ones that you don't need. For example, respondent ID. It's a unique number, but it's assigned by Hamda, but it's probably not what's relevant for you. So you may just drop this. So how do you do this? You select the drop columns here, and then the df, the variable that the data that it contains. The drop command, and then here's the drop columns. And once you do this and check the keys, they used to be respondent ID. Now it's gone, isn't it? Alternatively, you could just pick the columns you like. So the keep column in that list, I just give the name of the columns that I want. and then the df of, and then keep column and replace it with df. So now the df only contains these handful number of columns, okay? Not all of these. And that maybe is a good idea, because if some of the variables have like most of them missing and you want to still keep them in the analysis, then you're forced to drop those variables or fill it. And it's probably not the best thing if you're not even interested in using that variable. So choose your columns and rows first, and then do the handling. The first thing you probably are curious, and in Excel sheet, it's very easy to see, is that which ones are missing. So is NA not a number? You can click here and then it shows where it's missing. Here it's missing. When it's false, it's not missing. Okay. And if that is not too convenient, then if you have the df.isna and then sum it, then it will just sum by its variables. So for each variable, how many of them are missing? So this income actually has a lot of missing. Right? And then if you just want to know how in total, how many are missing, it's about 8,000 something. 7,500, yeah. So here's the sum of the sum that will sum it up. So now that you know that there are some missings, what do? There are a couple of choices I'll show you. First is just delete all the missing. So if anywhere it's missing, just delete the whole row. So if I do this, drop NA and how any, it will just drop. Okay, so what used to be 49,695 now we'll have only 41,581. Another way of doing it is, instead of deleting them all, which may be deleting too many, maybe we may fill it with some number like 0. Okay, and you can change it to 10 or whatever you want, -1. And 0 is a common choice, but you have to be careful. If 0 means something, you don't want to fill it with missing with 0. Isn't it? Also, you could just fill certain columns like income and population. We want to fill it with 0. You can do it here. It's a partial fill. I renamed it partial fill. You can just override it, and that's fine too. But the point is that you can just give the column name and fill NA with 0. That will fill it. And some of the things that are not number, you can also fill it with something different, like fill NA, and then you can just give the character. So if the lone purpose, which is not a number, if that's missing, just write down their missing information. So something like that you can do. Or you can forward fill or backfill. Ffill is forward filling, which propagates the last valid observation to the next. And bfill is the opposite, uses the next observation to fill the gap. So the usage is fairly similar to the previous one. Or you can use the mean to fill the missings. Okay. So for the going forward, let me just drop all missing. So the drop df. So the drop df, which we have it, I'm just gonna replace it in the df so that we have 41,000 sort of observations. The next thing is, what if we have duplicate data? So are there any rows duplicated? So df.duplicated checks the duplicated, and you can just put those rows and separately name it. How many are there? 1,700 around are duplicates. You can just check how many are duplicated in the particular variable, and it will give you, that's of course, a whole bunch of duplicates. Another way of doing it is that, yeah, if you want some variable, let's say applicant income thousands, if that's how many of them are unique, there's 781 unique variables. So what do we do with the duplicates? You can just duplicate any duplicates, which is here. Okay. Okay, so that's about cleaning up the data. Sometimes you want to transform the data. For example, the income. The income may be in the thousands. It can be 30,000 income, 250,000 income, and on all that. Maybe that number is not that important, but rather the bins, whether you're poor, you're an average, or you're the rich wealth. That's maybe important. Here is how to create a wealth level variable based off that income. So how do you do this? The applicant income, that's the variable I'm going to use. So I'm looking at the value, and the label poor, average, rich, I'm going to give it. in terms of the category bins from 0 to 30, 30 to 100, 100 to 250, isn't it? And so forth. So here is how that variable is being created. Another thing that people often do is that check the outliers, isn't it? An easy way to do it is the box plot. So if you think about the income, maybe a problem, you can just plot a box plot. In the Seaborn, SNS, I nicknamed this as SNS, the Seaborn library. There they have a box plot, and it plots the box plot where there's a whole bunch of data clustered, but also here, some that are fairly outliers. Then check the income here, or the summary statistics. Another thing that one could do is that, well, remember we should check the data types. We can create a data frame that just contains the numeric. Let me just name it df numeric. And how do you do it? That the selected dtypes exclude the object, which keeps only the integer and floating number variables. So if you look at the df numeric, that is only there are only 10 afterwards. There used to be 10, but now there are only 5 columns because only 5 columns have numbers. And again, you can just save it in your local directory. So the df numeric actually is a good way to see it. If I want to save it at Hamda numeric only CSV file and download it, if I click it, it will download it on my computer. So then you can look at it here. The numeric only will contain these and the ones that are based off the numeric that was basically created from this income variable. You can see that that's here. Right? So these are some basic steps that are used for cleaning up data using the pandas. It's often used. There are more tricks like standardizing the variables and all, and you can explore them as well. If you look up for Panda on Google for some tutorials, they also give excellent and alternative ways of doing similar stuffs here. Right? So this is how you clean up data with Panda. Thank you.